All right, next up, the parallel access theorem. This corresponds with problem 19. And this is kind of just a niche little bit of rotational kinematics, rotation of inertia, this kind of thing. And the parallel axis theorem states, say we have an object, we can call it a disk, because that's what they really use in this problem, but it could be anything, a disk, and we have a moment of inertia of how much it takes, and measuring how much it takes to rotate this object around the center. It's moment of inertia I, and we call it I naught because, or I center, sorry, because that's moment of inertia around the center. And the parallel axis theorem states, we're rotating, we want to find the moment of inertia of this same exact object around a different point, not the center. Say we move it to like here all of a sudden. And if we want to rotate it around the same axis, so if before we were rotating it around the vertical axis, it goes up, assuming that it's the same, or it's parallel, this is a bad drawing, but assuming that, or if they're parallel, the two axes that you are now trying to rotate it on, this new moment of inertia, which is I naught, or I nu, we get I naught equals the I center plus m times d squared, and this is d, the distance you bring it. So it basically just tells us how to find a new moment of inertia if we're rotating about the same axis through a different point on the sphere, or not on the sphere, on the object. And so we apply this to problem number 19. We have just a normal disk. We know the moment of inertia of the center IC equals 1/2 mr squared. And it's asking us if the disks are now like rotating about this point on the edge. We don't know what the radius is, it's just r, or I guess we do know what it is. But so now we're trying to rotate it around this point, and it's the same axis, the vertical axis, so they're parallel, and the parallel axis theorem fits in. But basically, I naught, the new moment of inertia, equals 1/2 plus md squared. D is r, plus mr squared. And now this adds up to 3/2 mr squared, but it does ask us what the moment of inertia of the two disk system is. So if we look at the two disks, we get all this times 2, which is 3 mr squared. Answer choice B.